Hello everyone, welcome. Now this is lecture number 16 of Horner differential equation. If you haven't watched lecture number 1 to lecture number 15, go through all the previous videos, right? Super. So in lecture number 1 to 13, we have been solving problems based on um, differential equations of first order and first degree, right? Those are lecture number 1 to lecture number 13. In lecture number 14, we have started linear differential equation, that is second and higher order linear differential equations with constant coefficients, right? In lecture number 14, we have started that. In 14, 15, we have been discussing the solutions of second and higher order linear differential equations with constant coefficients, right? Super. So I strongly recommend you to watch all the previous videos before getting back to this video, right? Because this is the continuation of the previous class, right? This is a continuation of the previous class. Already we have completed type 0, right? What is type 0? When RHS is 0, right? When RHS is 0, it is called type 0. And what is type 1? RHS is of the form e power ax. And what is type 2? RHS is of the form sine ax or cos ax, right? So we are in type 2 now. So I'll just give you the notes, show the notes of previous class so that you will have understanding what we are saying, right? For the type 1, previous class we discussed about type 1 problems, right? So we have a linear differential equation a naught dny dx n minus 1 dn, right? Sorry, it's dn. So dny by dxn an dn minus 1 by dxn n minus 1 up to any rs is e power ax, right? So in the previous class we discussed about this, and then we have started type 2 also. So what is type 2 is RHS is of the form sin ax or cos ax, right? So what is the method of solving that? And the solution is y is equal to cf plus pi. The method of finding cf is same. Method of finding cf is same. The only thing is the method of finding pi, particular integral, will vary depending upon the RHS. So when if you are in type 2, that is if your RHS is sin ax or cos ax, so replace d square by minus of a square and proceed. This is what I have said in the previous class, right? You have to replace d square by minus of a square. We have solved two problems based on this, right? So solve d square plus d plus 1 of y is equal to sine 2x. How to find pi? 1 by d square plus d plus 1 of sine 2x. So here a is 2. So replace d square by minus of a square. So minus of 2 square, this is minus 4. So you have to replace d square by minus 4. So you will have something like d minus 3. After that, you have to take conjugate here. So multiply by its d plus 3, d plus 3. So this will be a minus b, a plus b formula, which is a square minus b square. Then numerator we have d plus 3 of sine 2x. So different multiply this inside. So d of sine 3x plus 3 times sine 3x, right? So you will be having, this is what you will have, right? So d plus 3 of sine 2x. So differentiation of sine 2x is cos 2x into 2. So d of something means you have to differentiate. 1 by d of something means you have to integrate, right? And then we have discussed second problem also. So we have solved two problems on type 2. So we'll continue solving problems on, we will continue solving some problems based on type 2, right? After that, we'll move on to type 3 and type 4. So we'll try to complete type 3 and type 4 also in this class, right? I think outside there is some road work is going on, right? If you are getting some noise, means please adjust with it. I think, is there any outside noise you are getting? Is there any outside noise? It's not that big, right? You can adjust with it, right? If there is any outside noise, right, like a mission noise, that the road mission noise, you can just say you will cancel this class, right? It is disturbing for me, but I don't know how this video, whether this audio, whether the captures are captures or not. Okay. So I'm looking for comment. No, sir, as of now, no. Super. Okay. I think this mic is working good so that it doesn't capture the noise. Okay. So we'll continue third problem, right? So type 0 we have completed. Type 1 we have completed. Type 2, in the previous class, we have solved two problems. Now we'll start with third problem of type 2, right? If you haven't watched the previous classes, go through all the previous classes. Okay. So we'll move on to problem number 3. It is on type 2, right? Okay. So solve b square plus 9 of y is equal to cos 4x, right? Is equal to cos 4x. Okay. Solution. So this is type 2, right? Because you can see R is the form sin ax or cos ax. Here it is cos 4x. So it is type 2. Okay. The general solution. The general solution is given by y is equal to CF plus PI. So find CF. So to find CF, just find the auxiliary equation, which is m square plus 9 is equal to 0. To solve this equation, you will have m square is equal to minus 9. So m square is equal to I square into 9. So m is equal to plus or minus 3i, right? That means 0 plus or minus 3i. 0 plus or minus 3i. So we have a complex root, right? We have one pair of complex root. So we have one pair of complex root, which is of the form alpha plus or minus I beta. In that case, your CF will be e power alpha x into C1 cos beta x plus C2 sin beta x. So your alpha is 0 here. So e power 0x. C1 cos beta is 3 here. C1 cos 3x plus C2 sin 3x. This is your characteristic function. Now to find Pi, so it is 1 divided by d square plus 9 of cos 4x, right? So replace d square is equal to minus of a square, right? So it will be minus of a is 4 here. So it will be minus of 4 square, which is minus 16, right? Which is minus 16. So you have to replace d square by minus 16. D square will always be negative here, right? Because it is minus of something square, which is always be negative. So this will be 1 divided by minus 16 plus 9 cos 4x. So this will be minus 1 by 16. It will be minus 1 by 7 cos 4x. We can stop here. This is the required particular integral, right? The previous problem we have some d term also. In that case, we have taken conjugate, but here we don't have d term here, right? Suppose if you are getting 0 means what you will do? Suppose if your denominator is 0, what you will do? You will multiply x and then you differentiate the denominator. You need to make use of that type 1, right? Okay. So therefore, the general solution is y is equal to CF plus PI. CF is, this will be 1. So we will have C1 cos 3x plus C2 sin 3x minus 1 by 7 cos 4x. This is your solution, right? So we'll move on to fourth problem. To solve d square plus a square of y is equal to sin ax, right? Is equal to sin ax. Okay, now we will solve this. This comes under case type 2, right? Type 0 is r such as 0. Type 1 is e power ax. Type 2 is sin ax or cos ax. So then general solution is y is equal to CF plus PI. So to find CF, the auxiliary equation is m square plus a square is equal to 0. You will have m square is equal to minus a square. So I square a square. So m is equal to plus or minus ai, right? M is equal to plus or minus ai. That is 0 plus or minus ai. Therefore, your characteristic function is e power 0x c1 cos ax plus c2 sin ax, right? Yes. Now to find pi, so it is 1 divided by d square plus a square sin ax. Sin ax. So replace d square is equal to minus of a square. So here a is a, right? Sin ax. A is a only. So replace d square by minus a square. So this will be minus a square plus a square into sin ax, right? So we will have 1 by 0 of sin ax. In that case, what you have to do? Multiply x. You need to make use of the type 1, right? Differentiate this, we will have 2d sin ax. Or no? So if you 0, if you have denominator 0, we will call that as absurd, right? We will call that as absurd. So if you make use of k type 1 here. So if you have 0 in the denominator, what we will do? We will multiply x and differentiate this term, which is 2d, right? A square is constant, so its derivative is 0. This can be written as 1 by 2, 1 by d of sin ax, right? So we know 1 by d is integration, right? So 1 by d is integration sin ax dx. So this will be x by 2 integration of sine ax is minus cos ax divided by a, right? This is the required particular integral, right? This is the required particular integral. Okay, therefore the solution is y is equal to cf plus particular integral. So characteristic function is c1 cos ax plus c2 sin ax plus particular integral is minus x by 2a cos is. This is your general solution. Is it clear? Okay, now we'll move on to fifth problem. We'll move on to fifth problem now. Solve find the general solution. Find the general solution of d square y by dx square plus 4y is equal to 8 times cos 2x, given that y is equal to 0 and dy by dx is 0 when x is equal to 0. So why they have given this initial data? Just to find out the values of arbitrary constant, right? So it can see it is a second order linear differential equation with the constant coefficients, and it falls under type 2 because it is of the form sin ax or cos ax. Therefore, the general solution is given by y is equal to cf plus pi. So first we will find cf. So to find cf, so we have an equation of what? D square plus 4 of y is equal to 8 times cos 2x. This is a given equation, right? What is the auxiliary equation? It is m square plus 4 is equal to 0. So we will have m square is equal to minus 4. This is I square into 4. It implies m is equal to plus or minus 2i. So it is of the form alpha plus or minus I beta, right? Alpha plus or minus I beta. So you will have alpha to be equal to 0, beta is equal to 0. So our characteristic function is e power alpha x into c1 cos beta x plus c2 sin beta x. This is your characteristic function, right? Now you find particular integral, that is 1 divided by d square plus 4 of 8 times cos 2x, right? 8 times cos 2x. So take this 8 outside. So replace d square is equal to minus of a square. So minus of a is 2 here. So it will be d plus d square by minus 4. So we will have this to be minus 4 plus 4. 8 times cos 2x. This is 0, right? So 8 into 1 by 0 cos 2x. We don't have 8 here, right? We have this 8 outside. So it is absurd, right? So whenever your denominator is 0, we'll call this absurd. What you have to do? Multiply x, differentiate this denominator. We will have 2d, and we have 8 times cos 2x, right? So you have to you take this 8x outside, right? Because 8 into x is outside by 2 also, right? 8x by 2 outside. So we have 1 by d of cos 2x, right? Remember, you consider only this term, right? 1 by d of this term. The x is to the left of this, right? That means you don't bring this x here. Okay, we have to integrate this function. Okay, wait a minute. Yes. So this x is left of this, right? That means you integrate only this term, 1 by d of cos 2x. So we will have 4x into integration of cos 2x dx, right? So don't bring x inside and don't integrate x into cos 2x. In that case, you have to use integration by parts, right? Don't do that. So it is the left of this, right? So that means you consider only the right of this. What is right of 1 by d? It is cos 2x only, right? This 8 is constant, no problem. You can take that outside. So this will be 4x into the integration of cos 2x is sin 2x by 2. So if I cancel this, 2x sin 2x is your particular integral, right? 2x sin 2x is particular integral. So therefore, the solution is y is equal to cf plus pi. So cf is c1 cos 2x plus c2 sin 2x, and your pi is 2x sin 2x. This is your solution, right? Now we need to find C1, C2. Why? Because they are given the initial data. It is given that y is 0 and dy by dx is 0 when x is 0, right? Okay, so that is when y is 0, when x is 0, y is 0. That is when x is 0, these both happens, right? So we have when x is 0, y is also 0. So when x is 0, y is also 0, right? So that means you put y to be equal to 0, c1 cos 2 into 0, c2 sine 2 into 0 plus 2 into 0 sine 2 into 0. I'm just putting x to be equal to 0. This term will be 0, this term will be 0, right? Because sine 0 is 0, this 0 into something is 0. We have cos 0 is 1. So we have c1 is equal to 0, right? Because this is c1 into 1. So c1 is 0. Okay, now we will find c2. So further it is given that when x is 0, dy by dx is 0, right? And see when x is 0, dy by dx is 0. So first we will find dy by dx, right? First we will find dy by dx. So what is dy by dx? So differentiate this c1 derivative of cos 2x minus sine 2x into 2 plus c2 derivative of sine 2x is cos 2x into 2 and differentiate this term. So 2 into product rule. So x into derivative of sine 2x is cos 2x into 2 plus I'll keep sine 2x as it is. Derivative of x is 1, right? So I'm just applying UE method, right? U into v dash. So I'm keeping x as it is. Derivative of sine 2x is cos 2x into 2. I'm keeping sine 2x as it is. Derivative of x is 1. Now we know c1 is 0, so this will be 0, right? And it is given that dy by dx is 0 when x is 0, right? So substitute for 0 when x is 0. So when x is 0, this will be 0, right? These two we will, and this is also 0, right? Because 0 into something. This will be 0, this will be 0. We will have only this term, which is 2 times c2, 2 times c2 cos 2 into 0. So again you can see c2 is also 0, right? This implies 2c2 is equal to 0. This implies c2 is also 0. That means your both the arbitrary constants are 0. So in that case, just substitute c1 to be 0, c2 to be equal to 0. So therefore, the general solution is y is equal to, we will have only 2x sine 2x, right? Because this is 0, this is 0. This is the required solution, right? You can check it out. You just substitute y to be 2x sine 2x here. So differentiate that twice and add and multiply 4 into y, you will get 8 cos 2x as an answer, right? Just substitute y to be here. So differentiate this y twice, so you can find the value of this. 4 times y, so you'll have 8x sine 2x. Add both, you will get 8 cos 2x, right? Okay, is it clear? Any more 60 problem? More 60 problem. So solve e square plus 1 of y is equal to sin x sin 2x, right? So what is sin a sin b? Sin a sin b is cos a minus b minus cos a plus b divided by 2, right? So you have to remember these basic formulas: sin a sin b, cos a cos b, sin a cos b, cos a sin b. You have to remember these 4 formulas. So this is same as cos of a minus b. So x minus 2x is minus x. Cos of a plus b will be x plus 2x divided by 2, and cos of minus x is same as cos x, right? Cos of minus x same as cos x. This will be cos x minus cos 3x divided by 2. This is same as 1 by 2 of cos x minus cos 3x, right? So that means both the questions are same. So whenever you have sin x sin 2x, make use of this formula. So what is the central solution? Central solution is given by y is equal to cf. Remember, I'm going to find pi1 here. Okay, let us like this, right? It is given by 1 cf plus 1 by 2 of pi1 minus pi2, right? For pi1, I'll be using cos x. For pi2, I'll be using cos 3x. So we'll find the c of pi1, pi2. So what is c of it is a solution of m square plus 1 is equal to 0. So m is equal to plus or minus I. That means 0 plus or minus 1 into I, where CF will be e power alpha x, C1 cos beta x, C2 sin beta x. Beta is 1 here, right? Now you find PI1. So PI1 is 1 divided by d square plus 1. PI1 is cos x, right? Cos x. Now replace d square is equal to minus of a square. So it will be minus of a is 1 here. So it will be minus 1. So replace d square by minus 1. So we'll have minus 1 plus 1 by cos x, which is 0. So multiply x and differentiate this denominator 2d of cos x. So x by 2, this will be integration of cos x dx, right? Because 1 by d of cos x. It will be x by 2 integration of cos x, integration of cos x sin x. So x by 2 sin x is your pi1. Similarly, you find pi2. So pi2 is 1 divided by d square plus 1 of cos 3x. So replace d square is equal to minus of a square. It will be minus 9. So minus 9 plus 1 cos 3x. This will be minus 1 by 8 cos 3x is your pi2 value. Therefore, general solution is y is equal to CF plus, substitute back here, right? The general solution 1 by 2 pi1 minus pi2, right? So this will be what is CF? CF is, this will be 1. So C1 cos x plus C2 sin x plus 1 by 2 of pi1. So 1 by 2 of pi1 is x by 2 sin x minus 1 by 2 of pi2 is minus 1 by 8 cos 3x, right? If you want, you can multiply this 4 inside, multiply this 2 inside, so that you will have the general solution, right? Okay. Okay, I'll give you an exercise problem based on this, based on the same method. Now the problem is exercise. So solve d square plus 1 of y is equal to cos x sin 3x. So cos a sin b. So cos a sin b is sin a minus b. Sin a plus b minus sin a minus b divided by 2, right? You make use of this formula so that you will have again 1 by 2 pi1 minus pi2, right? See, so you'll get the answer very easily, right? Okay. See, you have to remember these 4 formulas, right? You just make a note of these 4 formulas. So first formula is sin a sin b. Sin a sin b is cos a minus b minus cos a plus b divided by 2, right? Second formula is sin cos a cos b. So cos a cos b is cos a minus b plus cos a plus b divided by 2. The third is sin a cos b. Sin a cos b is sin a plus b plus sin a minus b divided by 2. Fourth is cos a sin b is sin a plus b sin a minus b. So you just remember these 4 formulas, right? So here we have sin a sin b, which is cos a minus b minus cos a plus b by 2. And here we have cos a sin b. So cos a sin b is sin a plus b minus sin a minus b divided by 2, right? So you can also get from these kinds of problems, right? So it comes under type 2 only. So don't think that yeah, multiplication, right? We can convert this to formula so that it will be converted to type 2, right? Okay. I'll write down this problem in this page, right? So seventh problem is exercise problem. The same problem you have to do. exercise problem to solve some exercise problems. To solve d square plus 1 of y is equal to cos x sine 3x, right? This is your seventh problem. Eighth problem is solve d square plus 4 of y is equal to cos 4x sine 4x. So you have to make use of cos A sin B formula again. Ninth is solve d square plus 2 of y is equal to sine 2x cos 4x. Right, so all three problems, you just make use of these formulas to convert to type 2, so that we will have PA1, PA2, make use of this, right? Okay. Okay, is there any doubt up to now? See, we don't need to take constant. Excellent question, Sarah. We don't need to take any constant after integration, right? Actually, there is a theory for that. There is a theory for that. You want to explain next class, right? A very good question. In solving this type of integration, we don't need to take plus c, right? Okay. Okay, so on to seventh problem. It is not 7. 8, 7, 8, 9 are exercise. On 10th problem. Okay, 10th also you can take an exercise. All b square plus 4 of y is equal to 4 plus sine square x, right? So you can put sine square x as 1 minus cos 2x by 2, right? This is same as 4 plus 1 by 2, 1 minus cos 2x, right? So that means this will be 4 plus 1 by 2 minus cos 2x by 2. This is your pi1 plus pi2 minus 1 by 2 pi3, right? So for pi1 and pi2, make use of type 1, and for pi3, make use of type 2, right? This can be done as 4 into e power 0x. Can be done as 1 by 2 e power 0x. So replace d by 0, right? For pi1 and pi2, for pi1 and pi2, solve by type 1, right? And for pi3, to solve by type 2, right? You take this as 4 into e power 0x, so replace d by a. So here a is 0, right? Problem is very easy. We'll move on to 7th problem now. Okay, so solve d square y by dx square plus 2 times dy by dx plus 10y plus 37 sine 3x equal to 0, and find the value of y and find the value of y when x is 5 by 2. It is given that if it is given that y is 3 and dy by dx is 0 when x is 0, right? See, when you look at the question, don't think that it is type 0 because r is 0, right? So it is not, when you consider this entire term, you have to take this term to that side, right? It comes under type 2 only, right? Okay. So clearly it is a second order linear differential equation with a constant coefficient and it falls under type 2, right? So we have d square y by dx square plus 2 times dy by dx plus 10y is equal to minus 37 sine 3x, right? Same as d square plus 2d plus 10 of y is equal to minus 37 times sine 3x. So the general solution is given by y is equal to cf plus pi. So first we will find cf. The auxiliary equation is given by m square plus 2m plus 10 is equal to 0. M is equal to minus b plus or minus root of b square minus 4 times ac divided by 2 times a. So minus 2 plus or minus, this will be 4 minus 40 is minus 36. Root 36, root of minus 36 is 6i divided by 2. So we will have minus 1 plus or minus 3i. If we take 2 outside, so it is of the form alpha plus or minus I beta. So we have one pair of complex root. So it is e power alpha x into c1 cos beta x plus c2 sin beta x. This is your characteristic function, right? It is your characteristic function. Now we will find pi. So pi is given by 1 divided by f of d. So d square plus 2d plus 10 of minus 37 times sin 3x, right? So take this minus 37 outside. It will be 1 divided by d square plus 2d plus 10 of sin 3x. So replace d square is equal to minus of a square. Minus of a square is 3, so it will be minus 9. This will be minus 37, 1 divided by, so d square is minus 9 plus 2d plus 10 of sin 3x. So minus 37, 1 divided by, so it will be 2d plus 1, right? 10 minus 9 is 1, sin 3x. In the previous problem, we don't have d here, right? Only we have d square term and constant term. If you have d, no problem, right? You have to take conjugate now. So 1 divided by 2d plus 1. So 2d minus 1, 2d minus 1 sin 3x, right? This will be minus 37. So 2d minus 1 of sin 3x divided by a plus b, a minus b, it is a square minus b square. And we know d square is minus 9, right? So whenever you find d square, substitute that. So it will be minus 37. So 2 times differentiation of sin 3x minus sin 3x divided by 4 times d square is minus 9 minus 1. So this will be minus 37. So differentiation of sin 3x is cos 3x into 3 minus sin 3x divided by, so this will be minus 37, right? Minus 37. These two will get cancelled. So we will be left with 6 times cos 3x minus sin 3x is your required particular integral, right? It is your required particular integral. Now it is given that you have to make use of this condition now. So what is your solution? Therefore, the solution is y is equal to cf plus pi. So cf is e power minus x, c1 e power minus x, c1 cos 3x plus c2 sin 3x plus pi is 6 times cos 3x minus sin x, right? This is your cf. So it's your solution, right? Okay. Now we have to find the value of c1, c2 now, because it is we have to find the value of y when x is pi by 2, that we can find later. It is given that when x is 0, y is 3, right? It is given that when x is 0, y is 3, right? When x is 0, y is 3. So that means you put y to be equal to 3, x to be equal to 0. So we'll have e power 0, c1 cos 0, c2 sin 0 plus 6 times cos 0 minus sine 0. So this will be 0, this will be 0. So we will have C1 into 1 plus 6 C equal to 3. So we will have C1 to be equal to minus 3, right? We have C1 to be equal to minus 3. So they are giving this to find the value of the arbitrary constant C1 and C2, right? And it is given that when x is 0, dy by dx is 0, right? dy by dx is 0. So we'll make use of this condition now. First, we need to find dy by dx, right? So we know y. So we'll find dy by dx. C1 is constant. So I'm going to apply UE method, right? So I'm going to keep e power minus x as it is. Differentiation of cos 3x is minus sine 3x into 3 plus I'll keep cos 3x as it is. Derivative of e power minus x is e power minus x into minus 1, right? Plus C2 into e power minus x sine 3x. So I'll keep e power minus x as it is. Derivative of sine 3x is cos 3x into 3. Now I'll keep sine 3x as it is. Derivative of e power minus x is e power minus x into minus 1. And differentiate this term. So 6 into cos 3x is minus sine 3x into 3 minus sine 3x is cos 3x into 3, right? This is dy by dx. Now dy by dx is 0 when x is 0, right? When x is 0, dy by dx is 0. So that means you put x to be equal to 0. So we will have dy by dx is 0 when x is 0. So when x is 0, this will be 0, right? Because sine 0 is 0. 0 into something is 0. This will be 0. This will be 0, right? Because when x is 0, sine 0 is 0. Sine 0 is 0. 0 into something is 0. This will be 0. So when you put 0 here, 0, 1, 1, right? Because cos 0 is 1. So we will have C1 into, the entire term will be 0. 0 plus, this will be 1, this will be 1. We will have minus 1, right? This will be 1, this will be 1. We have minus 1, right? And here we have C2. When you put 0 here, 1, 1, 3, right? 1, 1, 3. So e power 0 is 1, cos 0 is 1 into 3 plus 0, right? This term is 0 minus 3 times cos 0. So we will left with C1 minus C1 minus C1 plus 3C2 minus 3, right? And you know C1 is minus 3. So this will be 0 is equal to C1 is minus 3 plus 3C2 is equal to minus 3. So we'll have 0 is equal to 3 times 3C2 minus 3. These two will get cancelled. So we have C2 to be equal to 0, right? C2 is 0. So therefore, general solution is you substitute the value of C1, C2 here. Therefore, general solution is y is equal to CF plus P8 that we know. What is CF? E power minus x. So C1 is minus 3, right? So minus 3 times cos 3x plus C2 sin 3x. This will be 0 because C2 is 0 plus 6 times cos 3x minus sin 3x. This is your required solution, right? Minus 3 times e power minus x cos 3x plus 6 times cos 3x minus sin 3x is your required solution. We need to find what is the value of y when x is pi by 2. We need to find y when x is pi by 2, right? When x is pi by 2, what is the value of y? Minus 3 e power minus pi by 2, right? Cos 3 pi by 2, 6 times cos 3 pi by 2 minus sine 3 pi by 2. I'm just putting x to be equal to pi by 2, right? Pi by 2, pi by 2, pi by 2. Now, we have e power, yes. This will be, what is cos 3x only, right? Not cos x. A minute. Yes, right only, right? Okay. So find Arthur's values now. What is sine cos 3 pi by 2? What is cos 3 pi by 2? It will be cos of pi plus pi by 2, right? Cos pi plus pi by 2 is what? So we have pi here. So pi plus will be here. All silver teacups. So here tan and cot are positive, right? So all silver teacups. So here tan cot are positive. So cos is negative. So minus cos pi by 2, which is 0, right? Because cos pi by 2 is 0. So this that means the value of cos 3 pi by 2 is 0. So the entire term will be 0 now. And again this entire term will be 0 now. Right? So we will only have minus sine 3 pi by 2. So what is sine 3 pi by 2? So it is sine pi plus pi by 2. So sine pi plus. So again this it comes in a third quadrant. Again minus sine pi by 2 minus 1. Sine pi by 2 is 1, right? Okay. So value of sine 3 pi by 2 is minus 1. So 1 is the required answer, right? So when x is pi by 2, the value of y is 1. Is it clear? When x is pi by 2, so therefore x is pi by 2, y is 1. This is the requirement, right? Cos 3 pi by 2 is 0. You can substitute here. You can check it from here, right? Therefore, find the value of y when x is pi by 2. So that the value of y is 1 when x is pi by 2, right? Super. We'll move on to 12th problem. So solve d cube plus 90. Now we are moving on to some solving some higher order, right? As of now, all 11 problems, it is either all second order only, right? We haven't solved higher order. Now we're going to solve some higher order. It is d cube. All 11 problems you can see, we have only d square terms, right? We don't have higher orders, but we will now we'll solve some higher order problems. Okay, so the solution. General solution is given by y is equal to cf plus pi. Now we'll find cf. So to find cf, so what is auxiliary equation is m square plus 9m is equal to 0. Sorry, m cube. If we take m outside, you will have m square plus 9 is equal to 0. So m is equal to 0 and m square plus 9 is 0. Means m square is equal to minus 9. So m is equal to plus or minus 3i. So we have 0 is one root. So we have one distinct root and one pair of complex root, right? One pair of complex root. Therefore, your CF will be C1 e power first root, which is 0x, plus this is complex root. So e power alpha x into C2 cos beta x plus C3 sin beta x, right? Will be C1 plus e power 0 is 1, e power 0 is 1, C2 cos 3x, C3 sin 3x. This is your CF. Now to find PI, this is very important. So to find particular integral, is given by 1 divided by d cube plus 90 of sin 3x, right? Now we have to replace d square by minus of a square, right? So replace d square by minus of a square. What we can do is you just take one d outside here, right? You just take one d outside here, or else we can also do like this. Okay, so we will do like this, right? So this can be written as d square into d plus 9d. See, any higher order can be reduced to d, because even if it is d power 5, we can write that as d square to d. That means we know value of d square. So you will always get the terms of d only here. D term and constant term only. So we will have sine 3x. So replace d square to be minus of a square. So minus 9, right? A is 3. This will be minus 9d plus 9d sine 3x, right? So d cube writing as d square into d, and we know d square is minus 9. This is 1 by 0 of sine 3x, which is absurd, right? That means you have to make use of type 1 now. So here, let's call this as star, multiply 1x, differentiate the denominator, it will be 3d square, 3d square plus 9, right? 3d square plus 9 of sine 3x. Now again, replace d square is equal to minus of a square minus 9. So it will be x into 3 into minus 9 plus 9 sine 3x, right? This will be x into 1 divided by minus 27 plus 9 sine 3x. So it will be minus 18. So minus x by 18 sine 3x is your particular integral. Therefore, general solution is y is equal to CF plus PI. So CF is C1 plus C2 cos 3x plus C3 sin 3x minus x by 18 sin 3x, right? So that means any higher order in finding PI, when you are replacing d square by some term, you will only have here functions of d and constant term only, because even if you have d power 7 even if you have d power 7 here, you can write this as d square into d, right? Now these all are numbers, because d square term is some number, so that means some number into d. So you always reduce to d here, function of d here, right? Okay, we'll move on to 13th problem. I think I'm getting my point, right? So whatever higher order may be, if you are replacing d square by constant term, here in the denominator you only have d and constant term only, right? So solve d minus 1 whole square, d minus 1 whole square, d square plus 1 whole square of y is equal to sin x, right? So here you can see it is a sixth order equation. Here we have d square term, here we have d power 4 term. It will be sixth order equation, right? No problem. We'll do this. So solution is given by y is equal to CF plus PI, right? So to find CF, the auxiliary equation is given by m minus 1 whole square, m square plus 1 whole square is equal to 0. This is the auxiliary equation, right? Now we can see m is equal to 1, 1. 1 is a root repeated twice, and m is equal to plus or minus I twice, right? Because we have whole square here. That means we have 1 is equal to equal roots, and we have plus or minus I again twice. So what is the characteristic function? So write the characteristic function for this. So C1 plus C2x e power m1x. Write the characteristic function for this. What is the characteristic function for this? E power alpha x into C1 plus C2x cos beta x. Okay, already we use C1, C2. So we'll start with C3, C4, C5. So C5, C3, C4x cos beta x, C5 plus C6x sin beta x, right? Here it is of the form 0 plus or minus I, which is alpha plus or minus I beta. So it is C1 plus C2x e power x. So alpha is 0 here, so it will be e power 0x into C3 plus C4x cos beta x, beta is 1, C5 plus C6x sin x, beta is 1. This is your CF, right? Okay, to find PI, To find pi, so pi is 1 divided by d minus 1 whole square, d square plus 1 whole square of sine x, right? So what you can do is you always write a single term, right? Write a single term. That is, here you just expand this and multiply this inside, write a single term. So what is d minus 1 whole square? So d minus 1 whole square is d square minus 2d plus 1. And what is d square plus 1 whole square? A plus b whole square. So a square plus 2 times ab plus b square, right? When you multiply this, you will have, what about d minus 1 whole square? D square plus 1 whole square, you have to multiply these two terms, right? So you will have, so d square into these terms. So you will have d power 6 plus 2 d power 4 plus d square, right? So d power 6, 2 d power 4 d square. Now multiply 2d with this term. So you will have minus 2d power 5 minus 4d cube minus 2d, right? I'm multiplying 2d with all these terms. So minus 2d power 5 minus 4d cube minus 2d, multiply 1 with this term. So we will have d power 4 plus 2d square plus 1, right? Now we add it up all the like terms. So d power 6 we have one term, and d power 5 we have one term, right? So minus 2d power 5 minus 2d power 5. And what about fourth power? So you can see 2d power 4 plus d power 4. This is 3d power 4. So this will get cancelled. That is, we are done with that. And what about cube terms? So we have only one cube term, which is minus 4 times d cube. What about square terms? D square plus 2d square, which is 3d square minus 2d plus 1, right? So no problem. However long this may be, whatever power you may be, we are going to replace d square by minus of a square, which is minus 1 here, right? So this d power 6 can be written as 1 divided by, what is d power 6? D square, d square, d square. So minus 1, minus 1, minus 1, which is minus 1. Minus 2 times d power 5 is d power 4 into d, right? D power 4 into d. And 3 times, what is d square? It will be d power 4 is plus 1. See, d power 6 is d square, d square, d square, which is minus 1, minus 1, minus 1, minus 1. D power 4 is d square into d square. So minus 1 is plus 1. And what about d cube? D into d square. So d square is minus 1. So d cube is minus d. What about d power 5? D power 4 into d. D power 4 is 1. So 1 into d, which is d. Right? This is what I'm writing here. Minus 4 times d cube. So d cube is minus d minus 2d plus 1. That is what I said in the previous problem itself, right? Here you will only have, here you are only going to get some functions of d and constant term only. So d power 5 is d. D power 5 is d only, right? D power 5 is d. D power 4 is 1. D cube is minus d. D square is d. So you're going to, you will be having 1 divided by minus 1 minus 2d plus 3 plus 4d minus 2d plus 1 into sine x. So this will be 1 divided by, so 4d, so minus 2d, sorry. So minus 2d is 4d. It's correct, right? Minus 2 times d power 5 is d power 4 into d. This d. D power 6 minus 2 d power 5. Is there any mistake I have made here? e power 6 is minus 1 minus. Here we have 3 plus 1. I think I made mistake anywhere. Just check with this simplification. Wait. Yeah, I missed one term here, right? So plus 3d square e power 6 is minus 1. D power 6 minus 2 d power 4 minus 2. D into d square is minus 1 minus 2d plus 1, right? Now you will have minus 3 will be added up with this, right? You can see this 0, right? This 0, right? So you can see minus 2d is minus 4d. Minus 4d plus 4d is 0. 3 minus 3 is 0. 1 minus 1 is 0. So everything is 0 in the denominator. That means what? You have to multiply x and differentiate this denominator, right? Okay. So this will be multiplying x. Correct only, right? It is not plus 2, it will be minus 2d only. What is d power 5? Yeah, minus 2 d power 5, right? D power 5 is d power 1 to d. D square is minus 1. So minus 1 into d, which is plus d only. So it will be minus 2d only. Minus 2d plus 3 plus 4d minus 3. It will be plus minus 2d only. So it will be 0, right? So that means we will multiply x here. We'll multiply x and differentiate the denominator, right? This is your denominator. So differentiate this. So d power 6 is 6 d power 5 minus 10 d power 4 minus 10 d power 4 plus 12 d cube plus 12 d cube minus 12 d square plus 6d plus 6d minus 2 into sine, right? Now again you replace d square to be minus half a square, which is minus 1 here, right? It will be x into 1 divided by 6 into d power 5 is same as d, right? D power 5 is d square into d. So it is minus 1 into d, which is plus d, right? Minus 10 times d power 4 is plus 1. 12 times d cube is d square into d. D square is minus 1, so it will be minus d. Minus 12 times d square is minus 1 plus 6d minus 2 of sin x. So x into 1 divided by, so we have 6d minus 10 minus 12d plus 12 plus 6d minus 2 sin x So you can see 60 plus 60 is 12d. 12d minus 12d is 0. Right? 12d minus 12d is 0. So here we have 12 minus 10, which is 12 minus 2 is 10. 10 minus 10 is 0 again. So you'll be getting again 0, right? D power 5 is d. D power 4 is 1. 12 d cube minus 12 times d square is minus plus 60 minus 2. Okay. Again, we are getting 0 as an answer, right? That means you have to differentiate this term, multiply x again, differentiate once again, right? Multiply x again and differentiate once again. I think this will take time, right? What a solution. Is it clear up to now? If we go in this method means it will take time. So the derivative of this will be 30. We'll try for some other method. Know the answer for this. If you do in this, you'll get the solution. Right? I search for answer for the problem. Okay, you just take on a problem exercise, right? I draw a solution for this problem. When you take this problem exercise, you differentiate this until you get the non-zero denominator, right? I'll take this exercise, right? I'll send this solution in a Telegram group. It will go long, right? If you differentiate this once again, you will have 30 d power 4 minus 40 d cube plus 36 d square minus 24 d plus 6. You replace d square. d square by minus 1 until you get the solution, right? It's very simple only, right? Don't think it is big. Very simple only. Only thing is I don't know the answer for this problem. We have done the answer to be x by 4 sin x. We are not getting x by 4 as an answer, right? We have done the answer to be x by 4 sin x. Is there any sign mistake we have made? D power 6 minus 2 d power 5 2 d power 6 d power 5 and d power 4 plus 2 d square 6d minus 2. Okay. Replace d square by minus 1, you will have d plus 1, you will have minus 6d will be 0. Here we have minus 10 plus 12. 2 minus 2. That means you have to repeat, right? So that means you multiply x again, differentiate, you find f double dash of d sin x, you proceed, right, until you get the required answer. Okay. I will move on to type 3, right? Then move on to type 3. Is there any doubt up to type 1 and type 2? So type 1 is RHS is of the form e power x. Type 2 is RHS is e power ax, sin ax or cos ax. We will move on to type 3, right? We will move on to type 3. So type 0 is RHS is 0 and type 1 is RHS e power ax and type 2 is sin ax or cos ax. Now we move on to type 3, right? RHS is of the form RHS is of the form polynomial equation of x. It's of the form polynomial in x. Polynomial in x, right? R is polynomial in x. It will be like x squared plus 2x plus 1, x cubed plus 3x plus 1. So we have polynomial in x. So type 0 is RHS is 0. Type 1 is e power ax. Type 2 is sin ax or cos ax. And type 2 is sin x or cos x. Type 1, type 3, right? Okay. So how to do this type of equation, right? That is, we have a linear differential equation. So a naught d power n plus a1 d power n minus 1 and so on up to an of y is equal to a polynomial in x, right? A polynomial in x, right? So it is a polynomial in x, right? So what is the general solution? It is cf plus pi. General solution is y is equal to cf plus pi, right? Cf plus pi. Now, how to find pi? That is the important thing, right? CF is same. How to find pi? That I will let you know in problem solving, right? How to find pi? That I will let you know in problem solving, right? Okay. So you make use of you note this formula, right? So what is 1 minus x whole power n? So 1 plus x square plus x cube and so on. And 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube and so on. Right? So you remember these two formulas. Remember these two formulas. These two formulas are very helpful in solving this kinds of problem. Okay. Now we'll solve the problem directly. In solving problem, I'll let you know how to find PI, right? How to find PI. So for type 0, there is no PI, and for type 1, RHS is e power ax, that is replace d by a in finding PI. And for type 2, replace d square by minus of a square in finding PI. Now in type 3, there is another method to find PI. That is what we're going to discuss now, right? We'll directly get into problem. To solve d square plus 2d square plus 2d plus 2 of y is equal to x square. Now you can see it is a polynomial in x. It is a polynomial in x. That means it comes under type 3, right? Okay. So what is the solution? The general solution is y is equal to cf plus pi, right? So first we find cf. To find cf, so we have an auxiliary equation. This m square plus 2m plus 2 is equal to 0. M is equal to minus p plus or minus root of b square minus 4 times a into c divided by 2 times a. So minus 2 plus or minus, this will be 4 minus 8 is minus 4. So minus 4, root of minus 4 is 2i divided by 2, minus 1 plus or minus I. Therefore, you can see we have one pair of complex root. So your CF is e power alpha x, C1 cos beta x, C2 sin beta x, right? So alpha plus or minus I beta. E power alpha is minus 1. Very important, right? So to find pi, right? To find pi, so pi is 1 divided by d square plus 2d plus 2 of x square, right? So here, what is the least degree here? We have degree 2 term, degree 1 term, and constant term. So least degree, you see this as a polynomial now, right? So d square, what is the least degree here? 1, 2 is the least degree, right? That is this constant term. So take the constant term outside, right? So that means this will be 1 plus d square plus 2d by 2. Is it clear up to now? So you see which is the least degree, right? D square 2d 2. As of now, think as a polynomial d square 2d plus 2. Even though d is d by dx, right? No problem. 2 is the least degree term, right? So 2, take 2 common here. This will be 1. Here there is no 2. Divide by 2. Is it clear up to now? Okay. Now this is 1 by 2 half, right? I'm going to write this term as 1 plus d square plus 2d by 2 whole power minus 1 of x square. I'm taking this term to numerator. Now we know the formula for 1 plus x whole power minus 1, right? So what is 1 plus x whole power minus 1? 1 minus x plus x square and so on, right? And so on up to x square. It will go on and on. Is it clear? I'm just expanding 1 plus x whole power minus 1 is 1 minus x plus x square and so on, right? Since we have square term x square here, d square, d is you have x square, right? So what is differentiation? It will be 2x. What is d square? We have differentiate twice, so it will be 2. What is d cube? It is 0, right? First derivative is 2x, second derivative is 2, third derivative is 0. That means from d cube, everything will be 0, right? D power 4 is 0, everything is 0. So up to d square only, we're going to have some values. After d cube, it will be 0 only. So I'm just stopping here, right? I'm just stopping this expansion here. So this is 1 by 2, 1 minus d square plus 2d by 2 of x square And here if I expand here, a plus b whole square formula. So a square plus b square, a square plus 2ab plus b square, right? So 2 times ab. So 2 times d square into 2d. So we will have 4d cube d square plus d square plus 2d whole square, right? A square plus 2 times ab plus b square divided by 2 square is 4 of x square. Remaining term will be 0, right? Remaining term will be 0, right? Because we will be having the higher powers. We will be having every term will be like d cube, d power 4 and so on. So here also you can see, you can omit this term, right? You can omit d cube, you can omit d power 4 because d cube is 0, d power 4 is 0. You take only this term in this here. So we have this to be equal to 1 by 2 of 1 minus d square plus 2d by 2 of x square. And here we're going to have 4d square by 4 is the only term that will be here. It has the values, right? Other will be 0. Other will be 0, right? See, I'm just dividing everything by 4. D power 4, d cube of x square is 0, right? D power 4 of x square, d cube of d power 4 of x square means you have to differentiate x square 4 times. D cube of x square means you have to differentiate x square 3 times. And we know we differentiate x square once, we'll have 2x, twice 2, thrice it is getting 0. So you consider only 4d square by 4 of x square. This is 1 by 2 of 1 minus, multiply this x square inside. So 1 by 2 d square of x square minus 2 will get cancelled here. D of x square plus d square of x square, right? 4 will get cancelled. So this will be 1 by 2, 1 minus 1 by 2, d square of x square. First derivative is 2x, second derivative is 2. First derivative of x square is 2x, second derivative of x square. First derivative is 2x, second derivative is 2, right? So this will be 1 by 2, 1 minus 1 minus 2x plus 2, right? So again minus 1 minus 1 is 0. So you will have I need to multiply x square inside, right? So that means 1 into x square this will be, right? Multiplying x square inside, x square into 1, x square into this term and this term, right? So it will be x square. So we have x square. We have x square minus 1 minus 2x plus 2. So this will be 1 by 2 x square minus 2x plus 1, right? It's the required particular integral. Therefore, solution is, if you understand the single problem, everything will be very easy. Pf plus pi. Pf is e power minus x c1 cos x plus c2 sin x plus pi is 1 by 2 x square minus 2x plus, right? So RHS is a polynomial in x. You consider this as polynomial now. See this just for understanding. You take the least power outside, least term outside, least degree outside. So you consider this as x. 1 plus x whole power minus 1. 1 minus x plus x square and so on. I'm just putting dot 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 just because every term will be 0 after that, right? Because we have d is 2x, d square will be 2, d cube itself is 0, right? Okay. So is there any doubt up to now? Okay, now move on to second problem. Solve d square minus 4d plus 4 of y is equal to x square plus 2x. So it is a polynomial in x, right? It is a polynomial in x. Therefore, the general solution is given by y is equal to, you take this as pi1 pi2, right? So cf plus pi1 plus pi2, or you can also take this entire term also to be pi, right? That is your wish. But I'll suggest you to write, you take this as PA1 with this PA2, right? Okay. Now you find a characteristic function for m square minus 4m plus 4 is equal to 0. So you find the roots here, you will get m to be equal to equal roots. So you have c of to be equal to c1 plus c2x e power 2x, right? Now you find PA1. So PA1 is 1 divided by, or else you can also choose P to be okay. Let us okay. If you want, you can also write PA1, PA2. If not, you consider this full term as PA. Right? This is your wish. Let us keep this full term as PA, right? X square plus 2x. Okay. So this will be d square minus 4d plus 4 of x square plus 2x. Now you have to take 4 outside, right? Degree 2, degree 1, 0. You see there's a polynomial now. That means 1 plus d square minus 4d by 4. And here we have x square plus 2x. This will be 1 by 4, 1 plus d square minus 4d by 4 whole power minus 1, x square plus 2x. So 1 plus x whole power minus 1. So 1 minus x plus x square, right? 1 minus x d square minus 4d by 4 whole square and so on into x square plus 2x, right? Now this will be 1 by 4. So multiply this x square plus 2x inside. So 1 into that term will be x square plus 2x minus 1 by 4 of d square minus 4d into x square plus 2x, right? So we have x square plus 2x. So d is 2x plus 2. d square is 2. d square is 2, right? d square is 2 and d cube is 0. So that means from d cube everything will be 0. So you don't need to consider d cube term, d power 4 term, d power 5 term and so on. So here you will be having 1 by 16 a square minus 2 times ab plus b square of x square plus 2x, right? Now you can omit this term, because d cube is 0, d power 4 is 0. You consider only this term, right? So this will be 1 by 4 x square plus 2x, and here minus 1 by 4 d square of x square plus 2x, and if we multiply this inside, we will have plus 4d by 4 x square plus 2x, and this will be 16 by 16 d square. So we will have d square of x square plus 2x, right? So this will be 1 by 4 x square plus 2x minus 1 by 4 d square. So first derivative is 2x plus 2. D square is 2, right? So you will have 2. You can refer here, right? And this will be d of this term. So d of that is 2x plus 2. 2x plus 2, d square of this term. So 2x plus 0, 2. So we'll have plus 2. Right? So this will be 1 by 4 x square plus 2x minus 1 by 2. So 2 1s are 2 2s are plus 2x plus 2 plus 2. This will be 1 by 4 x square plus 4x, right? 2 2s are 4. So 4 minus 1 by 2. So you will have this term to be equal to x square plus 2. Okay, what is term we are getting? We have x square plus 2x d 1 minus x plus x square minus square by 4. We have plus, so we have this to be x square. We have this to be x square square plus 4x plus 4 minus 2. So 1 by 4 square plus 4x plus 7 by 2. Right? This is a required answer. Is it clear, right? So we are doing correct only, right? Solve d square minus 4d minus plus 4 square plus 2x. So 1 by 2 x square plus 4x plus 7 by 2 is your required particular input, right? Yes. So as of now in this class, what we have seen is we have solved two problems on type E, which is polynomial in X, right? So next class, what we will do is we will continue more problems. We will solve more problems on type 3, and then we'll move on to type 4, right? So type 0 is RHS is 0. Type 2 is RHS is e power x. Type 0 is RHS is 0. Type 1 is RHS is e power x. Type 2 is RHS is e power sine x or cos x. Type 3 is RHS is a polynomial in x, right? So in the next class, we will continue from third problem, right? So here it is our PI. So therefore, the general solution is given by y is equal to CF plus PI, right? So we know CF and we know PI also. Just add it up to get the required answer. Add it up to get the required answer, right? Okay, we will solve more problems in the next class, right? Start completing type 4 also in this class. We'll stop here. We'll continue more problems in the next class, right? Okay, thank you.